What's up, guys? We're going to be continuing here with Chapter 7, Section 3, where we're looking at more multiplication properties of exponents. So you want to pause and copy this down right here. The words, it says to raise a power to a power, you multiply the exponents. In other words, if I have a power a to m and that whole thing is raised to m, then that's the same thing as a to the mn, where I multiply those. Or numerical examples, a or 5 to the 4th raised to the 2nd power is the same thing as 5 to the 8th. And here's why this works. Let's look at a really simple example. If I have 3 squared and I have that value cubed, that means the same thing as 3 squared times 3 squared times 3 squared. And if you remember from our former section, if I have same bases and I'm multiplying, I add the exponents. So this is the same as 2 plus 2 plus 2, or repeated addition. Repeated addition is the same thing as multiplication, so we could just take the shortcut here and do 2 times 3, which equals 3 to the 6th. All right, so make sure you have that copied down. That's what we're going to be looking at today. That's kind of the big gist of today's lesson. First, not so much a funny as it is awesome. Sometimes you just need a baby ninja. Look at this kid go. Ha! Whoop. I could probably watch this for hours. It's so awesome. Look at him go, man. And that's a really cute kid. Oops. And that's a little disturbing, but still awesome. Okay, so let's keep going to simplifying a power to power raised to a power. So just like I said before, this just means you multiply these. So I have n to the 4 times 7 is going to be n to the 28. This one right here, I multiply these two powers, so that's going to be x to the 2 over 6, which simplifies. Always simplify if you can. X to the 3rd. And that is all you're doing, is just multiplying these powers. So here's a couple for you to try. Go ahead and pause. The answer will be up in 3, 2, 1. All right, so that's what I got. Check yours against mine. Again, this should be super simple. It's just multiplying here. All right, simplifying an expression with powers. It says, what is the simplified form of y cubed times y to the 5 halves to the negative 2? All right, so the first thing that we need to do on this one is go ahead and raise this power to a power. So I'm going to start out with y cubed times, and then I'm going to do this times this. So I have y to the 5 halves times negative 2. So I'll go ahead and make that over 1 because these 2's are going to cancel. And what I'm left with here is y cubed times y to the, I'm left with a 1 and a 1 here. So 5 times negative 1 is negative 5. So I get 3 plus negative 5 because it's same basis. So I get y to the negative 2. And you cannot leave your answers as a negative exponent. So that means that y goes to the basement. All right, so y 1 over y squared. So make sure you copy this example down because this is where it starts to get a little bit confusing. There's a lot of different rules at play here. Here's the rule that we learned today where I'm multiplying the powers, but this is a rule from a couple days ago. And this one is a rule from a couple days ago. So we're going to be combining all these things, so you need to make sure that you're referring back to your notes when you need to. Here's one for you to try. The answer will be up in 3, 2, 1. All right, so that's what I got. Check yours against that. Let's keep moving. All right, so raising a product to a power, you'll definitely want to pause and write this one down as well. It says to raise a product to a power, raise each factor to the power and multiply. It's not distributive property, but it's similar in the sense that this n goes to both of these things. If I have an exponent on the outside of parentheses, everything in the parentheses gets raised to that power. So ab to the nth power is the same as an bn. 3 x to the 4th is the same as 3 to the 4th x to the 4th, which multiplies out to 81x to the 4th. That's what we're looking at on this. This is one that a lot of students mess up on. They just leave it with that last part of the product. Be careful with that. So let's take a look at an example. It says simplifying a product raised to the power right expression represent the area of the square. So you should remember that the area of a square is a side length squared. This is my side length. So the area is going to equal 5x cubed squared. Now, like I was just saying a second ago, that means all of this stuff gets squared. So what I get is 5 squared times x cubed squared. 5 squared is 25, and x cubed squared is multiply those two things. Power raised to a power you multiply is x to the 6th. So the area of this square is going to be 25x to the 6th using that rule. So again, it's technically not distributive property, but you are distributing that exponent to everything in those parentheses. So here's a couple for you to try. The answers will be up in 3, 2, 1. All right, so there are the two answers that I got. Compare yours. Let's keep going. Simplify an expression with products. All right, so it says, what is the simplified form of this big, ugly beast right here? So don't freak out. You just do this one step at a time. So I'm going to start here with this first one. I have n to the 1/2 times 10. And I'm going to write out the rest of it. Times. This 3 gets distributed to everything in here. All right, so times 4 cubed times m cubed times n to the negative 2/3 times 3. And then I go through and I just simplify each one of these things. So this first one I have n 1/2 times 10. Those cancel and I get a 5. So that's n to the 5th times 4 cubed, which is 64, I believe, times m cubed is just still m cubed, times these cancel out. I'm left with 1, so that's n to the negative 2. Now from here I have these things that I could go ahead and put those together. So I'm going to move this one over here. So I have 64 times m cubed times n to the 5 minus 2. All right, so I'm combining these exponents, same bases, so I can combine those exponents, which equals 64 m cubed n cubed. Now that's a lot on there, so you may want to go back and just double check everything, try to follow these steps, but absolutely make sure you have this copied down well so that you're not totally lost on this. Here's a couple for you to try. The answers will be up in 3, 2, 1. All right, so that's what I got. Be careful on that second one. That's a doozy. So really slowly go through all those steps and try to follow what was taking place there. Let's keep going. Raising a number in scientific notation to a power. So it says the expression 1/2 mv squared gives the kinetic energy in joules of an object with a mass of m kilograms traveling at a speed of v meters per second. What is the kinetic energy of an experimental unmanned jet with a mass of 1.3 times 10 to the 3rd kilogram traveling at a speed of about 3.1 times 10 cubed meters per second? So I'm going to literally just substitute these things in here. So I have 1/2, and then instead of m, I'm going to write the mass, which is 1.3 times 10 cubed. And then the second one is the velocity, but that's squared. All right, so I'm going to put that in parentheses. I have 3.1 times 10 cubed, and then that whole thing is squared, just like we were doing before. Parentheses on the outside, as long as everything's multiplication, that's going to go to both of those. So this is going to equal 1/2 times 1.3 times 10 cubed times 3.1 squared times 10 to the 3 times 2. All right, so here we go ahead and multiply these things out. You get 1/2 times, I'm going to do some rearranging here. So I'm going to put this 1.3 first, and I'm going to put this 3.1 second to try to get my powers of 10 at the end. And then I'll have my powers of 10, so I have 10 to the third times 10 to the 6th, because 3 times 2 is 6. And then I go through and work these problems out. So I have 1/2 times 1.3 times 3.1 squared. And those three things, when multiplied out, equal 6.2465 approximately. And then here, so this first part is this, and then these I just add the exponents. So that is 10 to the 9th. So the big thing here is that you still distribute that square. Scientific notation squared, everything in it gets squared. And that's what I get on that. I don't think I have a practice one on this one. Nope. So that's it. Hopefully you took good notes. I will see you all in class.